Welcome, everybody. Good morning. Welcome to reInvent. Thanks for joining us on a Monday morning to talk a little bit about what the Air Force is doing with the cloud. My name is Rob Nolan. I'm the Chief Technologist for Defense Programs here at Amazon. With me, I have Mr. Jay Bonsi. Jay is the Chief Technology Officer for the United States Air Force. Jay owns adoption and of programs for resilience, workforce modernization, security, IT, portfolio management for the Air Force. Industry veteran before coming to the Air Force. He's actually gone the opposite direction of a lot of folks. He's gone from industry to government. We've had some interesting conversations about that over the last day or so.
If anyone's thinking about that, it's an interesting journey about learning how the sausage actually gets made.
But prior to that, he was a longtime engineering leader at Akamai and helped design the Cloud One infrastructure, if anybody here works with the Air Force. Before we get started, I just want to get a couple of level sets here. So this is an executive level session. We're talking with Jay. We're thinking about like service level thinking, how the Air Force is looking at the cloud as an enabler for its strategies. How many people here actually work with the U.S. government or work with the Air Force? Okay, about half the room, and everybody else. So we're going to try to give you a little bit of insight into what the Air Force is thinking about. For those of you that work with the government and the Air Force, you're probably familiar with some of those terms, but we're going to try to avoid the DoD acronym soup as much as possible. So, and we are going to leave some time for questions. We'll leave about 10, 15 minutes at the end of the session for questions. We'll have someone circulate with a microphone. But so I guess we can jump into it.
Yeah. Also, I would say a lot of the lessons that the Department of the Air Force has apply very much to any sufficiently large organization. So companies that have undergone a lot of merger and acquisition have a very uneven tech baseline. Anybody who's in kind of a legacy business or really any government agency. So there's a lot to pick up here, kind of in that conversation.
I mean, what's the Air Force is about $1.5 million between active duty and civilian?
That's about it. We have about 800,000 users, and so if you were to look at the Air Force in terms of size, we would be in the Fortune 10 in terms of budget and people.
Yep. So I guess getting started, there's a couple of big things that the Air Force has been looking at in the last couple of years that's really predicated on the DoD's drive to modernize itself. Can you maybe start off by talking a little bit about the ABMS program? What does ABMS stand for, and what is that to the Air Force?
So ABMS is our Advanced Battle Management System, and it's a lot of things when you kind of peel the layers of it, but it is how do you digitally transform military operations at the core of it? How do you get data to where it needs to go? So the military is a sufficiently global operation. We need to be able to operate in any condition, in any place, very quickly. And that means that we have to have systems that are portable, ready to go, and can be operated by 18-year-olds. And having that very unique set of constraints forces us to design architectures that are resilient and can rise to that challenge. So ABMS is our, battle management is how airplanes, how we sort of task airplanes to go on various missions, whether or not that's intelligence, whether or not that's fighters, bombers, et cetera. The whole slew of everything that you would see in Top Gun.
Yeah, but then you have to think about that too as the joint effort as well, right? So the Air Force has airplanes, they move them around the world to do certain things, but then there's people on the ground, there's ships at sea. And so now you're starting to talk about this extending of a web of data, just from the aircraft down to the ground to give them insight. Today, I mean, can they talk freely between each other, like a ground force and an air platform, and can they send data back and forth? And
we can, but it's not as smooth as what we need it to be. And so, trying to have our missions and our operations be increasingly flexible and the ability to kind of reconfigure a military mission on the fly is the core of what it means to digitally transform it. And so that means, you have a certain set of operators out in the field, they're performing one mission, and then you need to be able to push a new mission set to them to be able to service a different platform or service a different set of missions. And that's very challenging. That's very challenging on the people side, it's very challenging on the air platform side, and it's also very challenging on the infrastructure side.
And so when you see on the slide here, we have a couple of things that are just kind of backdrop for the conversation we're going to have. On the right side, you see the Secretary's operational imperatives. So Secretary Kendall has established these 7 operational imperatives describing what the Air Force needs to be driving towards. And so we talked about ABMS, number 2 there. Talk to us a little bit about number 3 and number 6, the new platforms. What are those all about? Because as we get through the operational imperatives, we're going to start talking about how the cloud helps impact these. So I just want to set a little little context.
Sure. When we talk about air platforms, right, a lot of people have heard things out in the world about self-driving cars, right? So we've all seen kind of the cool stuff Tesla can do. We can see what a lot of automotive manufacturers are. And increasingly, it's a computer with wheels, right? Airplanes are the same thing, right? Our Joint Strike Fighter, F-35, our NGAD, Next-Gen Air Dominance platforms, these are just large bundles of sensors and data centers in the sky. And how we get data to and from them in a secure fashion and be able to process the sort of very, very, very sophisticated platforms, both for things that are human piloted or automation augmented, or increasingly in the future, single human pilot, lots of automated, helper aircraft next to it. So we're moving towards more and more advanced configurations of our air power projection plans. So that's what those systems mean, and our sort of targeting infrastructure is how we think about just reconfiguring the force away from war on terror operations to something that's more in a sort of a peer type competition. And so, again, we don't want to be in that sort of a situation, but of course, we have to be ready for it. So that is a change in scale, right? And really, when we talk about cloud and these things, cloud are one of those enablers of our ability to do this work at scale.
Yeah, it's interesting because there was the Air Force, there was an Air Force colonel, I think it was Boyd Fletcher, came up with the OODA loop. Mm-hmm. Observe, orient, decide, and act, right? So fighter pilots were trained to use those 4 steps as they were working through a tactical situation, right? Like figure out who's around you, orient yourself, where am I in relation to that, make a decision, and then do it. The modern colloquialism is sense, make sense, and act, right? And that's because everything is moving away from the Mark II eyeball to this like plethora of electronic sensors that are feeding data into a decision-making engine that's a computer to help accelerate a decision advantage. And so I guess that's a good segue. You think about these operational imperatives, you think about the CIO priorities for the Air Force. How does cloud fit into this? What is cloud helping you do to achieve some of these operational imperatives with these new platforms and new ways of the Air Force operating?
So for us, we think about cloud in a couple of really discrete ways, right? So first off, it is an automation platform. It's a way for us to be able to scale the amount of data that's coming in. So as we have more of this sort of automated sense, make sense, act type of OODA loop, whatever you want to describe it, that means our operations are going to be increasingly data-centric, and you need the cloud to be there in order to scale. So for us, we have all of these crazy operational challenges that get bigger and bigger as you continue to operate globally. Like there was a year, I've been in this job 2 years. For the first 18 months, I learned a new thing the Air Force did about every single week. So we have our own weather. So if you do anything with the United States weather projection, that comes out of Air Force weather. So our weather, our machine learning models for how we predict and model the weather, all of that's Air Force driven. We have the nuclear command and control infrastructure. We have our Air Force One. We have all of these things that we have to accomplish, all of our intelligence and cyber operations and just the scale of cyber events we deal with. So we need cloud to be there as a national asset for us to take advantage of to be able to meet the true scale of those challenges. And so it is this deep underpinning across our security, our how we do cost management, how we homogenize each of our mission sets to be able to take advantage of that scale. And it is truly the only way. We're not going to ship enough hardware to make data and AI work, and so those are cloud-first efforts. So it is a core competency for us, and there are so many implications as you kind of continue to go through the service about how we adopt it, how we pay for it, how we contract it, and how we encourage its use as our defense industrial base ecosystem brings capabilities to us. And so how do we work through partners and work through those key companies, right? So when we buy an aircraft, now we have something like NGAD or Joint Strike Fighter, we go out to a company that then also provides all of the infrastructure. And there is a challenge for us about, okay, F-35, are you providing the systems? Is the Air Force providing the systems? Are they natively cloud connected? Right, we provide the runways and the fuel, so we clearly have something to contribute here, but more and more things about the operation of the system comes from that defense industrial base. So this deep partnership in cloud is right in there alongside of it.
And I think one of the things that I've noticed working in this space for a while now is that the difference in silos of all those different systems, right? Each system discretely comes with its own infrastructure, and therefore you have all these people that are trained specifically on this one, but then if you need to move them over to this new platform or you have a new platform come in, it's this very kind of large training burden to bring people up to speed on this next infrastructure. And then you have this legacy tail, right? Where you have to think about how long am I going to keep this around? Like the B-52, I think, is going to be a 100-year airframe. And that wasn't invented at the time when we had the IT infrastructure. But imagine if F-35 was a 100-year airframe, like the amount of infrastructure that you're going to have to keep alive for that long makes sense. So when you level it with something like cloud, you can add a lot of advantage.
Yeah, we're seeing a lot using of cloud to uplift a lot of our legacy airframes, like 16s and 22s and some of the older elements, as well as some of the newer piece of infrastructure like our ISR ecosystem, right? Our unmanned aircraft. We can life cycle those pretty quickly because you don't have a pilot in them and you don't have to worry so much of the crash. So we have a lot of technology implications that we can bring even to those sort of legacy programs. And the siloing thing is really interesting, right? It's because the Air Force is so huge. And it's just like any very large organization. It's very difficult for every piece of the Air Force to know what every other piece of the Air Force is doing. And so you end up with dissimilar architectures and dissimilar risk tolerances and dissimilar mission sets. And trying to use cloud as a common language to bring things together to homogenize it is certainly it's a 10-year push. But it's a key thing that we have to do.
Yeah, and the Air Force doesn't fight alone. It's a joint effort,
it's a
right?
joint
so
effort.
Then you have the interoperability internally, and then you have the interoperability with other forces and our allies as well.
Getting our own house in order is enough of a problem rather than dealing with, and one of the great joys of this job is getting to bag on the Navy. And so if there are Navy people in the room, you are the second greatest Air Force in the world, and I have to get that out. Shush you. However, but we do have to work with them. We have to work with the Army. We have to work with coalition partners, right? Canada, the UK, NATO, and partners that we're not particularly great friends with. And how you do data interchange there is both a technical and policy challenge.
So we talk about all these legacy systems. We talk about the history of the Air Force. 1947, I think, is when it was established after World War II, and all the growth and all this kind of organicness. Like, how has the modernization effort to date been going for the Air Force in terms of using cloud and trying to start bringing people towards that kind of common baseline where it fits?
We started our cloud journey a number of years ago in the intelligence community, but inside of the Title 10 space, we really started that in earnest about 5-6 years ago. And it's going okay. We have 120 systems or so that are using cloud the way that you would think about it, not just software as a service platforms, but really a cloud service provider between Amazon and some other series of unnamed cloud service providers. However, that sort of first generation push was really cost focused, and we know that we have a few thousand discrete systems in the Air Force that are sort of cloud targetable, and trying to get the first 100 of early adopters, healthy systems that are reasonably funded and have program management offices that do the care and feeding for those programs. Great, those are the first 100. The next 2,900 are where the real challenge is, where we don't have all the funding we would need. We are trying to rack cloud migration against other priorities, such as modernization or having to pass a financial audit or having to ship new features. And so we're kind of in the thick of getting the right messaging out, getting the right contractual standards out, trying to hit the right contract lifecycle changeovers to say, oh, when you recompete this contract, make sure cloud is a piece of this, make sure that you understand that cloud is not about cost anymore, it is about resilience, it is about flexibility, and it's about the ability to quickly iterate over our systems. And that is That's going to be key. That's really on the legacy side of the house. On the systems that we are building and developing and modernizing today, they are cloud first. They are, our higher end systems, whether or not they are things like ground-based strategic deterrent or our cloud-based C2 ecosystems that service our NORAD, NORTHCOM air defense mission. Those things are cloud by default, and they're huge success stories because of it.
Yeah, I definitely want to get to those and talk about some of the things that enabled things like the cloud-based command and control. But before we do that, one thing that's maybe interesting for the audience is distinguish for us a little bit the difference between how you develop a modernization strategy for like a business system, which like many of us who've been in IT for a long time have worked on, versus a warfighting system. And how do you balance building things to help enable both of those, but have to be able to accommodate very different ways of using technology?
So the way that we would sort of talk about these things in very broad terms is that a business system, something like munitions ordering, or everybody has business systems, right? Whether or not you're buying staples or bullets, it doesn't actually matter. You're buying stuff, and you have to track that stuff, you have to pay that stuff, you have to deal with the invoices of that stuff. It's all, the fact that it's a military ordering system has no sort of bearing on that. The way that we sort of think about those business systems is they are cost-focused. You're a pretty cost-sensitive mission. Maybe you only need 2 nines of availability. Maybe something like a single AZ or single region is totally okay for what you're doing. You want the most amount of functionality for a reasonable price. And when you're doing that, it's very contractor-driven. You don't have to have enlisted people or officers really understand the technology of the system. You're working with an integrator, maybe you're buying it through a contract, and you are doing this so that you do not have to tax on-premise infrastructure or be in the real estate business of making server farms. So that's the sort of strategic underpinning of a business system. When you're talking about a mission system, then reliability actually goes up. And that makes you think about how you architect your data flows, architect your cloud infrastructure, and then architect how your service members in uniform actually interact with that technology. So if you're bringing an application with you into the field, that's a different set of constructs. It's the same cloud. Maybe under the hood, you're both running a Kubernetes cluster, but having your workload management be more a part of your operations is a different social construct and a different business construct than it is over on the business side. So when we're doing modernization for business systems, we've done a huge amount. Like one of the huge priorities for the Air Force is a clean audit opinion, and so we have Ernst & Young as one of our auditors. Has to make sure that we have all of the financial controls for something called FIAR. Which is our financial accountability pieces. And we have to get to a clean audit opinion per Congress by like 26. And we are on target to make it, but we have to rack those changes for how you do separation of duties to make sure, for instance, that I can't put in a purchase order and then also approve my purchase order, right? So going through each of the systems and re-architecting them to meet those separation of duties concerns, that has to come in and alongside of cloud. And we have to make a value-specific decision for each system to say, is going to cloud the right thing right now, or is it to kind of meet these other harder requirements that Congress has put on us? And it's gone both ways, right? Going to cloud will give you that flexibility and that ability to quickly reconfigure, quickly ship new versions of the application. And we've done the value stream analysis for our 80 or so financially relevant systems inside the business mission area. So we've done that work. It's been a huge amount of very uncomfortable navel gazing around how we actually ship those systems. On the mission system side, we start ground up from cloud and to ask the harder questions around how it impacts operations. And for us, we have this division of labor that meets the joint staff. You've probably heard like the A1, A2, A3, and it goes personnel intelligence, operations, logistics, planning, communications. But there are these traditional jobs that all roll up to the joint forces. And cloud breaks that system because architectural pieces of the cloud define the art of the possible for the mission. And so we've had to invert the thinking around how we design what we do in operations because of the cloud. And that's been hard. That's been very hard socially. Because oftentimes in the military, especially the Air Force, you would say, oh, I need an airplane that does this thing because this is what we think the fight would look like. And it needs to do this and fly this fast and use this much gas, have this type of munitions payload, et cetera. Okay, go to contract and buy that thing. Cloud doesn't work that way. Cloud can do anything. And so it's a matter of what we can figure out, what we can deliver with the money that we have, and then we can train people up to use that. And so very much the technology is driving the requirement cycle, and we are working through the internal pain of that. And so ABMS has broken a lot of our normal tech delivery processes by putting the tech at the heart of the thing that we're delivering. So it's been a huge social struggle to understand what the cloud actually means for the military, and not just the cloud, right? Resilient communications, the data flows, the policy pieces, how we do military-grade cryptography. All of those things bundled together have been a huge challenge for us, and it is going to be one of those things that we have to work through to get to that actual digital transformation. And again, this is not unlike any other large company that's done this.
That's a good segue over to, let's talk a little bit about how you're integrating the legacy stuff that has to stick around, right? Like you think about the big mainframes that are still going to be there for a long time, and just
death to mainframes.
Yeah, that's or like there's so many different Air Force installations around the world, and so we're building things in clouds. We're using that as kind of a leveling function to get a common infrastructure baseline, common services, but the clouds are in certain places, and the Air Force is in Montgomery, Alabama, and Rome, New York, and Kadena Air Base in Japan, and all over the world. Like, how are we interlinking all those legacy systems and leveraging the cloud to level that?
So we have the Air Force is, again, not unlike a very large organization. We have 180 locations across the world in most of, I think it's 48 of the 50 states. We have a fair number of continental U.S. Installations and a bunch abroad. Germany, Korea, Japan, UAE, a bunch of places, Italy. And whenever you operate on foreign soil, there's a whole host of data and data sovereignty issues. We can't just, we have customs whenever we bring equipment in. We have the status of forces agreements for how we can operate on foreign soil, how we interact with a foreign economy, et cetera. So we've had to, the way that we used to handle this, and the way we used to handle sort of this concept of disconnected operations, is we just ship a bunch of hardware there and it'll be fine. And what we've realized is that that's very expensive. You're replicating all of your services absolutely everywhere. That doesn't make a sane service strategy. And it means that you can't get more sophisticated. You can't ship better services absolutely everywhere. And we also don't have the real estate. We don't have the HVAC. I don't have the number of servers. I don't have 50 racks of gear in every location. And so that means to get more sophisticated, you have to break apart your dependence on localized hardware. Sorry, Hewlett-Packard. But really to find new ways to get to your data. And so that's been, for us, the first step in ABMS is to build our overlay network that will allow us to move data flexibly and globally. And whether or not that means, in theater if you're deployed someplace, or if you're in a partner nation, or whether or not you're in the continental U.S., we think about it as sort of Maslow's hierarchy of AI, and at the very bottom is connectivity. Beyond zero trust, beyond data security, beyond anything else, resilient communications is that bottom tier. And so that's a huge piece for what we're focusing on, and that involves our carrier strategy, how we're going to do SD-WAN globally, how we're going to tune those policies. It's been a huge area of focus for us as we continue to move towards a reorganization of the Air Force, but also a realignment of our technologies towards resilient communications as being a thing that we actually talk about, right? We can't just assume that we're going to be in a location, we're going to have some fiber to plug into, and the light's going to blink. It's going to have to be a lot more sophisticated than that. So we've been working through the internal pains of kind of uplifting that, and then what the security and policy pieces for how we do that and how we operate in foreign countries.
And you mentioned earlier we talked about the change in how some of the roles are shifting. The traditional, the 6 commo guy runs the communications in, gets the compute racks up and running, sets up that stuff. But now these capabilities are evolving to where there's going to have to be there's a split between stuff happening in the cloud, centralized data, centralized processing, and then edge processing, right, to help make decisions locally. And depending on the contention for network, the contention for a space you may be operating in, you may not be able to get back to the big cloud, right? But you'll be able to talk to people locally. So can you talk a little bit about how SD-WAN and kind of mesh networking is playing into some of the resilience stuff that you guys are planning?
Yeah, so SD-WAN for us is, we think there's a lot of different ways that you can use SD-WAN. And the way that the specific cut that we're looking at SD-WAN is how we prioritize connectivity when things start to get contested and austere. And so if we go, and we have, again, because this is a global mission set, each of the missions are a little bit different. So if you're operating, let's say you're a guest at some airfield in Romania, you can probably get connectivity from your Romanian hosts, right? They'll probably be willing to give you a Romanian internet connection. But if you're on some random island in the Pacific, there's not a random island on the Pacific ISP that you can hook up. There may not be cellular signal. So how do you bring that connectivity with you, whether or not it's military satellite, something like a Starlink or Viasat, and then how you take all of those different types of connectivity that you can bring with you. Once they start falling out and start getting contested, how do you choose what uses which satellite connection? And that's how we are thinking about SD-WAN. We're thinking about it as being our management of multiple modalities when you have connectivity. And again, you can do this in the continental US. You can think like, oh, we have 2 fiber connections. We just have to balance how they're used. And if traffic spikes up for some reason, make sure that we are emphasizing command and control traffic and de-emphasizing Netflix. Sorry, Netflix. So it's that type of policy determination that exists beyond traditional network like QoS management, that really focusing our operational people to think about, okay, seriously, in this location, what is the data, what data in what priority do you need so we can encode that in a policy? And that, again, that's part of that kind of uplifting of the technological baseline for us. But then the implication when you get to the compute side of the house is you have to get people to really think about what your disconnection sensitivity is and how that impacts how you design your applications. And so it becomes very much an architectural data replication conversation to say, how long do you think how tolerant do you want to be to being disconnected, right? Is the lights going to go out for a couple of minutes? Okay, that's one type of architecture. Like, oh, we're going to be disconnected for maybe a couple hours because we got to pick up and go. That's a slightly different architecture. Or there is this, we're going to live off the land for days at a time. That's a totally different architecture, and one that may not be reasonable going forward, especially because everything is moving to such a huge amount of data kind of gravity. You need to have the data to make good decisions and have good theater-wide situational awareness, and you may not have the sensor platforms you need nearby. So how do you make sure that you have that connectivity? So again, it falls back to the connectivity, your local compute strategy, and what your actual needs are. And it's no longer feasible to just bring 30 racks of gear with you everywhere and make a miniature base. That's not a reasonable concept of operations any longer.
Yeah, especially when you're on islands in the middle of the
Pacific Ocean, when you're on islands, right? You got to load everything back in the back of a C-130, and you're going to ship out someplace, and you get to this. You have very, very, very specific, like even weird little concerns about this, like how much power you have, or if anybody's worked with the AWS Snowball platform before, the way that our programs are typically structured is everyone gets different accounts. And if you've worked with the Snow platform before, just because we have different organizations doesn't mean they get their own Snowball, right? It doesn't make any sense. So we're not going to ship 30 Snowballs someplace. That's not efficient. So how do you get people to compact to be able to do resource sharing and those internal agreements? So again, the technology is going to drive new ways of thinking about the organization and new ways of thinking about operations.
Yeah, one of the funniest, we were working on a new platform for Snow, and one of the funniest requirements we got was it had to meet certain mill standards. And if you dig into those mill standards, there's one of them that just blew my mind is you have to test the enclosure to make sure that if the outside temperature is 40 degrees Celsius or below, that the enclosure keeps the temperature high enough that the computer can start, because at that temperature, computers won't turn on. Because apparently it's so cold that the electrons won't flow properly through the silicon or something. So these are just these crazy requirements that you guys constantly are uncovering, trying to figure out how to
There was
link
one
those
that I know we
together.
pushed to you guys about replaceable fans.
Yeah.
In the Snow platform, because fine particle dust from hot and sandy places in Southwest Asia, that shall go unnamed, that dust destroys data centers. And there's no amount of HVAC in the world that will get all those particles out. So you had to have specialized servers for, specialized server chassis for Southwest Asia.
Let's talk a little bit about interoperability, because I know you've got some interesting things you're doing there. When we talk about all these different silos, and we're talking about modernization, and I've got my little collection of things that I've built, and you've got your collection, and all of our friends here have their stuff, inevitably we're going to have to meet somewhere to agree on how we're going to interchange and exchange information or interact with each other. And I think everybody's familiar with the kind of urban legend about Amazon's API journey, right? Where there was like an edict that came down, and everybody's going to use APIs, and that led to a lot of the decomposition of monoliths.
We're trying to go down a similar journey
Yeah, so
now.
maybe you could tell us a little bit about that.
Yeah, so we've recognized, I came from the commercial world, and we see this all over the place. Where, you have a company that buys another company, and then you try, the business development guys say like, oh, this technology will work together, and inevitably it doesn't, and there's an ugly process where you find some shim layer where your two things work together, and that shim layer lives forever, and it just becomes part of an increasingly large number of shim layers. And we know that that is an anti-pattern, and that we shouldn't be doing that. So we're starting the process now of having the conversation around what an API standard would look like and how systems should talk to each other. And we've set out some really basic introductory rules for this, for this, and we're going to be publishing a reference architecture for public comment in January about what we think this reference architecture is going to look like. But it has to include things like, how do you credential software workers? And do so in a way that doesn't tie yourself to a particular cloud service ecosystem, or can work with on-premise, and you can meet your regulatory needs. And so some of our data interchange standards have regulatory components, right? So if you have a PII or PHI, the government has to mandate you handle that data in a certain way. So how do you make sure in your IAM system that your consumer has self-asserted that they are properly structured to handle health information if you have a health API? So we've thought through a lot of those business cases. We have a lot of the kind of initial reference architecture. We're looking for commercial products that fill the space. There aren't a lot of great commercial products that allow you to stand up your own IAM ecosystem. Most people do it first. Most sufficiently large organizations do it first party. And again, we're going to have to figure out how this interoperates with where the DoD, the large capital D DoD is going. So again, we're going to put it out for public comment, and hopefully we're going to start that conversation by kind of putting those things in the stand. But we know that APIs are going to be the future for us, and API first development in this incredibly vast partner ecosystem. So the difference between us and like an Amazon is I have to make sure that this is in contracts, that our defense industrial base will want to buy into this ecosystem. So driving the zeitgeist around this is the way that we are going to accomplish a joint interoperability world is key, and to make sure that we have those messages. So we're being very deliberate about how we deliver that interoperability message. Today, we are doing interoperability at the data tier through very large data platforms, and we're using that as a proxy for actual low-level data interoperability. So we have these big 6 data platforms for logistics, intelligence, cyber data, and we are papering over the organizational credential exchanges by going through these data brokers. And that's worked out great. That has really accelerated our analyst community. It's really accelerated our data collaboration, but it doesn't scale. It doesn't cover software control interfaces. It doesn't. It's very expensive to ETL a bunch of data, keep it stale-ish in a cloud someplace, and then hand it out. So we need to move past that ecosystem, and sort of direct data access through APIs is going to be that piece. And we know that it is going to be a part of a longer conversation, but we us in the Secretariat for the Department of the Air Force can only really impact the Air Force, so it's a matter of leading through influence and putting these ideas out there and getting people to buy into it. So we would love for that urban myth to be true. We would love for us to staple our API thesis to the door and have everyone say, that's a great idea, we'll do it, and hop on board, but we know this is a multi-year process.
Yeah, it seems like in DoD it's about seductive adoption more than it is about edicts, right? Because it's the military, you'd think if someone orders you to do something, you're going to go do it. But in reality, it's like the world's largest herd of cats, and they're all going in many different directions. And they'll come together when it's time, but if it's not time to all join forces under one common goal, then it's like everybody's kind of got their own thing.
We joke that the Air Force is, the motto of the Air Force is, but sir, right? We haven't, but sir, have you considered X? And so there is going to be a natural process, even though it is a military, even though it is a high power distance, a hierarchical, rigid organization, that driving that we are all doing this together because we have this shared vision is going to be the only way to make it work. Even though the Secretary could issue an order and it would go marginally faster. So there's a lot there.
Yeah, PKI, you mentioned PKI, it's just such a hard problem to solve, especially for machine-to-machine communication. And then you have the distribution of people at the edge, you have federation, you have all these different things. Who do I trust? Who's ultimately the kind of root of trust there? Yeah. And so I think that paradigm also extends itself to information flows. So I'm not going to say data, because data is like a way overloaded term, but information flows and how information moves between where it's generated and who consumes it and who uses it to inform decisions. I think that's super important. And you touched on some of the large 6 data platforms the Air Force has. Yeah. But can you talk a little bit about, because I think industry, commercial industry has the same issue of you have all these discrete silos of information scattered throughout your organization. You don't really have a good sense of who's authoritative, who's the catalog, what's the ontology, because those are all super necessary to inform labeling and use for training an AI or use for feeding for inference or making decisions. What are some of the things the Air Force is looking at the scale of the enterprise you guys have around that?
So we have our kind of chief data office that is driving a lot of the data standards and data interoperability and data architecture and adoption pieces. And even as we move to AI, all of that's, APIs, but also AI, I guess. All of that is table stakes for getting that right. So we are building a global data catalog as a part of our CDO team, which lives with us in the Office of the Chief Information Officer. We are also pulling together the different communities to make sure that our intelligence community, which operates, so we have Title 10, which is the sort of military, it's the U.S. code that gives the military's authority to be the military, and then we have Title 50, which is the intelligence community, which gives them the authority to do intelligence community stuff. They are funded differently. They have they descend their authorities from different folks, but it's all still the Air Force. And so one of the struggles is around how do you make Title 10 and Title 50 authorities and money and standards interoperate. So we're doing a lot of work in that area with our our A2, our intelligence folks. But it is a broad cut at, again, driving standards, driving the sense that standards are important, and even little things. We say, okay, if you describe a base, we're going to have a standard ontology for all the fields that this data set for a base looks like. If you describe an airplane tail, right, what are all the pieces of data and in what format? Just getting all of those things right is a challenge so that we can do better fusion operations between those platforms. And then getting the connectivity in what we're sort of calling our data fabric, getting that right is a huge part of what we're talking about now over the next year or so, to build things between platforms.
And I think in industry and in the government, those things have been tried before, right? But I think cloud is one of those places now where we have this common place we go meet to do it. Mm-hmm. And so I don't have to establish a network link necessarily, or I don't have to interconnect to data centers, or like I have this vendor's database and this vendor's database. There's open standards-based things that are in all clouds. Cloud
is great for that, but it doesn't get you out of the homework. Yeah. Right, and so people think like, oh, we'll just go to the cloud. And no, you still have to do all of those other things around standards and around rationalization and around understanding, the time phasing of your data. So there is still so much work to do. Cloud just allows you to spin the crank faster. And so again, when we had this sort of discussion slightly in the business system, you would not be able to iterate as quickly without cloud. And so going to cloud or starting in cloud because you know what you don't know is huge. So it's one of those, the data has to move so quickly that there would be no way to do it without that kind of automation that cloud underpins.
So we've talked a lot about the priorities, a lot of the different areas that you're focusing on. Let's dive into maybe like a little bit of an example of a system that you guys have worked on that's been successful. So before we talk about that system, tell us a little bit about what the Air Force has done to kind of give people guardrails, systems that they can inherit things from so that they don't have to reinvent the wheel and they can focus on innovating according to what the mission requirements are.
I like how you slipped reinvent in there. So,
did I?
Yeah, you did. Got it. For us, we developed something called Cloud One, which was we had a naming scheme where we had like Cloud One, Platform One, Mesh One. We went on this sort of kick where everything was a something one. Regardless, Cloud One is our enterprise cloud guardrails, and it provides a series of you should go to cloud and adopt it in a certain way. And it's a technical and social experiment around constraining cloud choices, and principally it's for business systems. So we ended up saying, okay, if you are going to the cloud, right, and just to be very Amazon focused on this, we're not going to allow you, we are going to force you to tell us why you can't use containerization first. Right, so if you're going to ship something in the cloud, you're going to use, in an Amazon context, you use Beanstalk, Lambda, ECS, EKS, et cetera. No infrastructure as a service. And if you do infrastructure as a service, you will have all of these other compliance things that you'll have to take care of: platform protection, platform management, your OS patching. Don't do any of that. You're going to go to containers first, and the guardrails are designed to make container-first ecosystems and PaaS-focused ecosystems easier. And so we provide identity, we provide web application filtering, we provide the IAM and VPC constructs for how you peer with a common services VPC. We have all of that stuff pre-wired. It's not perfect. There are going to be some missions that have to do their own platform protection for whatever cost or legacy reason. But we've been able to kind of squeeze 100 or so, 100, 120 missions into that box and more on their way. But again, it's been very much if you let everyone just go to the cloud and you just hand them a cloud root key, you're going to get crazy architectures and all of these other kind of vulnerabilities. And so we've tried to balance the Wild West with having guardrails that kill off innovation. And there's been a lot of lessons learned about what works and what doesn't work in those guardrails. And again, we're putting together the next generation of those services now as we do the contract changeover. So it's been a great experiment. And like I said, we've been doing this for 5 or 6 years with. And by the way, this also includes the business side of it. So how you pay for utility-based billing is very hard for governments, right? We have these things called continuing resolutions where I don't know if I'm coming to work on Monday. And so we get funded in these very weird ways, and then we have to kind of smooth that out to have utility-based billing and what that means for appropriations. And so, and all the government financial management pieces that underlie that. Like we have a hard budget, right? We can't borrow money, something called the Anti-Deficiency Act. So we have to pay all of our bills because we're the government. And so this means, cloud resource planning is very challenging. So we have a whole construct around making sure that we don't go over in our cloud billing, that we have financial guardrails as well as technical guardrails around what we do. And again, how we do the refactoring of legacy applications, like pick them up, take a look at them, figure out what services they should go to and what cloud service provider they should go to, drop them in, get them relatively stable, and then hand them back to a previous team who may or may not be super cloud savvy. And so we've done a lot of work in that. There's a lot left to do. And we're constantly doing kind of value stream analyses around how we can be doing that better.
So let's talk about a specific example of a success there, right? So CBC2, I think there's been some stuff in the press talking about that and how the IOC went great. Maybe help, and that was a clean sheet, right? That was a revamp of a legacy system that was built right after 9/11. And it's obviously very important, air defense stuff, what happened back in February, things floating over the United States. We want to make sure we can see those quickly.
The term I heard from a targeting people, so we had that balloon, that Russian or Chinese or whatever spy balloon thing. The term I heard from the operators was float around and find out. So that's my gift to you.
If you Google that, by the way, later, there's this awesome mission patch, but that's...
I think that's still the F-22's only confirmed kill is a balloon. And so the F-16 guys will tell you that's a failure of the F-22 platform.
But so CBC2, clean sheet design, we started from scratch there, and it was kind of enabled by Cloud One. Like, talk a little bit about how the architecture was able to evolve, how fast the team was able to move compared to like a traditional government program where you might have to go out and bid requirements and get a data center and get a prime in there to build all that, and then only then can you start even writing code.
Yeah, so we really, and one of our colleagues here is one of the folks who sort of stood that up, Josh Evans. It was a cloud-first initiative where we thought, okay, let's get FAA data into the cloud. So there is a role to play for the Air Force and for the FAA to kind of cooperate on air picture and starting as a cloud-first program and starting with, again, that clean sheet of paper where you didn't have an existing, you're not trying to force an old paradigm on the new thing. And so that allowed us to develop and ship that capability light years faster than what it was. And it allowed us to get through the regulatory and interesting pieces where, NORTHCOM and NORAD is a joint US-Canadian exercise, and that means we collaborate. We all share one airspace, and so that making sure that we would have Canadians looking at our data and vice versa became a key. And the only way to handle the true scale of all of that radar data was to do it in the cloud. And we're looking to kind of expand it as time goes on. But it forced us to build a cloud development pipeline greenfield and to do it the right way. And that was been absolutely, it's a huge success that we're trying to hold up more and more as being the way it should be done. One other plug I will give, again, one of the cool parts of my job, one other plug I will give to NORAD is NORAD Santa, which is also something the Air Force does. So we give credit to that, and I just remind my children every year that we're responsible for NORAD Santa.
Yeah, I think one of the things you said earlier about like what Cloud One does is it kind of says like up front, here is these architectural patterns that we've vetted, that we know work, we have compliance support for you on these things. So it reduces a lot of that kind of initial decision making that really isn't value driven, right? Like, well,
it is fear driven. It takes a lot of the fear out of adopting
Right.
cloud, which is say if you can take your CI/CD pipeline, you can get it into this vetted artifact scanning pipeline, and then it ends up in a managed PaaS environment with the right IAM roles, and then the way that we think about it is we have something called an ATO authority to operate, which is based upon some gigantic number of NIST controls for RMF. 700 or something like that. 700 things, which says, and it's all kinds of things, which is, does your data center have procedures to fail over? Well, okay, it's a cloud. We have that. It's automated failover, right? Does your data center have fire suppression? Okay, actually, we're inheriting that control from the CSP. Great, fire suppression, right? So all of the risks that you have of IT, every mission is supposed to cover that, and it would be too much of a lift to ask everyone, hey, do you have fire suppression? 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 But everyone still has to inherit that control. And so we take that on and say, here's a control package. We have all of that stuff answered for you. Those risks are handled. You as an organization need to focus on this amount of risk. And what the enterprise is doing is trying to eat up that licorice stick to take on more and more and more of the risk, so that, again, we can take the mental workload of delivering a capability legally and with best practice down to the ground in order to be able to make it go quickly. And CBC2, the cloud-based C2 folks, have done an amazing job of kind of working with those guardrails to be able to deliver very quickly. We ship new versions of that quite rapidly. And again, we're very proud of that.
Last question, and then I want to open it up for a little bit of Q&A from the audience. Appreciate you guys sticking it out with us. So you said something earlier, and I just like as a parting thought, I think a lot of organizations that have adopted cloud in the last, say 5 to 10 years are probably approaching the same inflection point you said the Air Force is, which is shifting away from using cloud as a cost driver, cost savings only, and then focusing more on things like resilience and actually getting the true benefit of using the cloud, right? The agility, the getting rid of undifferentiated heavy lifting, just all the things that you can take advantage of. Just maybe as a parting thought, like what are your takeaways on how people can kind of ask themselves how to approach that journey and what your thinking is as you start trying to push the Air Force in that direction?
So for us, we have to think about, we're constantly having to ask ourselves, are we taking advantage of cloud or are we just using cloud? And the problem is that we have this sort of mental thing where we said, oh, we paid for the cloud migration and now that's done. But when in reality, there are years of maturation where you say, okay, yeah, we have we have a bunch of virtual machines. Let's move off of that. Let's move to containers. Okay, let's skinny down those containers. Let's refactor them. Let's refactor. And the cloud enables those pieces, and we're trying to get the social pieces behind the budgeting and behind the messaging to say, there is so much value in the year 2 and year 3 generational leaps for cloud that we want people to focus on driving that value. So it is, and so we're using resilience and flexibility as those key terms, right? Which is to say, okay, you may be in the cloud, but it's sort of rickety. It doesn't automatically fail over. Maybe if it goes down or if you push bad code, right? How do you then focus on the outcomes rather than what you think the stated requirements are? So again, it's a big push to get people who are not native technologists to think about the implications of technology and how they budget and prioritize.
Yep. No, I think that the outcome-driven way of designing things is, what cloud was really made for.
Exactly.
Right? I think a lot of folks look to get efficiencies from using it, but now it's that next evolution of the journey.